So let's talk about the different levels of RAID. And I will tell you, by the way, there's more than just what I'm going to show you here. Okay, these are the main ones. Sure, I'll be honest with you, I based this primarily off of the objectives for the A+ exam, but these are also the most commonly used ones out there. All right, so here we have our bunch of disks, right? Let's talk about RAID 0, which is known as striping. In order to have RAID 0, you have to have at least 2 physical disks. And again, even though they are 2 physical disks, they will look like one logical piece of storage. And you can have more than 2, by the way. The illustration I have here is 2 because that's the minimum, but you can have 3 or 4 or 5. You can have many more. So if we say that we have data that needs to be written, right, and that data gets broken down into these blocks that are going to be written to a hard disk, what we do with RAID 0 is we stripe the data back and forth between the 2 drives. Or if there were 3 drives, we'd be going 1, 2, 3 between the 3 different drives and then going back to 1. Now here's the deal. This does add performance. And it's not write performance necessarily, but read performance is really where you get the benefit. Because when you're reading this data back, you can actually read the data back from both hard drives at the same time and improve, how fast you can read the data in. Because instead of just having one disk that's doing all the work, trying to feed you the data, you can have 2 of them doing the work. So there's no actual redundancy. There's no reliability here. There's no high availability here with RAID 0. But that is a very common form of RAID. Where we do have redundancy is with RAID level 1, which is known as mirroring. Now with RAID level 1, you will have exactly 2 disks, but again, they're acting as just one single logical drive. Here we have that same data, but in this case, what we're going to do is each piece of data, each block of data is being written to both drives to create a mirrored image. So that way, if one drive was to fail, the data still exists on the other drive, and that's why you have redundancy. Now, I also mentioned high performance, and the reason why is because there are now technologies that have been built in to where you can be reading block 1 from the one drive while you're reading block 2 from the other drive, and therefore, again, utilize both drives' performance to speed up the reading capability. Now, before we go into another level of RAID, I figured I'll mention there is where you can do a combination of more than one level of RAID. And we have what's called RAID level 10, as it's commonly known. But please keep in mind that RAID level 10 is actually not a level. It's RAID 1 and 0. And believe it or not, there's actually a slightly different version that is RAID 0 and 1. And the only difference between RAID 1.0 versus RAID 0.1 is whether you are doing a stripe of mirrors or a mirror of stripes. And if you look at the illustration, you'll see with RAID level 10, or 1.0, you end up with 2 mirrors that you then stripe the data back and forth between. Whereas with RAID 0.1, you end up with 2 stripes that you're striping data back and forth between, and those 2 stripes are then mirrored, a mirrored image of one another. All right? So keep in mind that you can do that. The last level of RAID that I want to talk to you about is something called RAID level 5. And this is a very popular form of RAID. And this is called striping with parity. In this case, you have to have at least 3 disks. You can have more, but you have to have at least 3. So if we take these 3 disks, again, representing one single logical drive, if we take our data, what's going to happen is that first block will be written to one drive. The second block will be written to the second drive, but then the third drive doesn't actually get data. You end up creating what's called a parity block that we throw onto that third drive. And we do that each time we stripe through the data. But we move the parity block. So now we're going to put 3 on disk 1 here, and then we're going to throw the parity block on disk 2 and put 4 on 3. And then we're going to, this stripe through will start off with parity, and then we'll do 5. And we'll do 6. Okay, so you see how that goes there? The idea here is if one of the drives fails, the parity block, and I'm not going to go into all the details about this, but the parity block can be used to reconstruct the missing data from the failed drive. And I will tell you that with RAID level 5, you get redundancy, as you can see here with the parity block. You get performance because you are striping. Now, I will tell you, there's actually a performance decrease on the right side of things because you have to do the formula for the parity. Okay, so the right side, not left and right, but right with a W, W-R-I-T. When you're writing, you have writing performance that'll slow down because you have to calculate parity. But the read performance, you are still getting to take advantage of the fact that the data is striped and you can read off multiple disks at the same time. But a third benefit that you have, even beyond mirroring, is see, here's the one huge drawback to using disk mirroring or RAID level 1. You only get to use 50% of the hard disk space that you spent your money on. Right? In other words, if you bought two 100 gigabyte hard drives and you did mirroring on those two drives, you have a total of 200 gigabytes of storage, but you can only utilize 100 of it, right? Because anything you write to one, you're also going to duplicate and write to the other. So you only get 50% disk space utilization. Whereas with RAID 5, if I use this example here with 3 disks, if those were each 100 gigabyte hard drives, we have a grand total of 300 gigabytes of storage that we purchased, but we can only store on 200 of the 300, right? Because 1/3 will be held aside for parity. But there you're getting 66% disk space utilization, right? You get 2/3. Imagine if this was 4 disks. Now you'd get 75% disk space utilization because only one disk would have parity. So 3 of the 4 you'd get to use. Or what if you had 10 of these disks? Now 90% of your disk space you actually get to store data and only 10% is left with parity. And the last thing I'm going to leave you with here before we wrap things up is keeping in mind that the scenario where you can bring multiple RAID together, you can also have RAID 51 or RAID 15. Again, we tend to put the numbers together and just say 51 or 15. It's really 5-1 or 1-5. And again, it's the idea of doing the same thing as 1-0 and 0-1. You can do striping with parity and then actually take that stripe and mirror it. Or you can go the other way around, where you can go ahead and you can have multiple mirrors representing each component of the stripe. All right, so that's how RAID works. And I will tell you that that does bring us to the end of this very long lesson. But to be honest with you, there's a lot of storage options out there, and you have to be familiar with all of it. All right, so if you need to, go back, watch any of this again. But the idea here is storage. In this lesson, we're talking about long-term, not permanent, right? Because things do break. But long-term storage or non-volatile storage, okay, in the form of floppy disks, which are kind of outdated. You have hard disks, which are obviously in today's world and will be into the future, whether it be magnetic or SSD. We have our optical drives. That's also something that is little by little being phased out, but it's going to be quite some time, I think, before optical storage is completely phased out. And then keep in mind that storage can be internal. It can also be external. We have all sorts of different technologies for connections, and you have to know all of it. So with that, brings us to the end of this lesson. I thank you for watching this lesson. Whew, that was a long one. Go get a cup of coffee, and I'll see you in the next lesson.